Okay, so set 2, remember I'm dividing these up a little bit so you can take your time. We are still looking to solve for a variable first. Still in a system, and I look here and I have standard form, and I don't need it in standard form. I'm using substitution. We need to find one variable, and we're looking for a coefficient of 1. And I look, and I'm like, oh, the only one here with a coefficient of 1 is my y, so I'm going to solve for that y. So I'm going to write 8x minus y equals negative 6. Remember, we move the x away first, and it's positive, so we subtract. So negative y equals, I'm going to put it in mx plus b, so negative y equals negative 8x minus 6. Here's the difference. This one has that negative 1, remember? That negative in front of that y. So I have to be careful and make sure that now I divide not just the negative y, but everyone. You have to be very careful with your signs when you are looking at a y or an x with a negative value. That was a negative 8, so that's a positive 8. That was a negative 6, so that's a positive 6. Good news. Now we know why. So let's go plug that into the other equation. You cannot use the first one. You have to plug it into the second equation. And it's going to go right here. So 2x minus 3, that y value is 8x plus 4. I'm sorry, 8x plus 6 equals 4. Now we are going to simplify. That's the first step in solving. Simplify each side. So remember, distribute. 2x. That 3 is negative, so negative 24x. Negative 3 times 6 is negative 18 equals 4. Combine my x terms there, so I have negative 22x minus 18 equals 4. Looks like we're going to add 18 to both sides. And we have negative 22x, these cancel, equals 22. Divide by negative 22 on both sides, and our x value looks like it would be negative 1. So now we know x, we have to go find the missing y. Now remember, use the easy one. I think the top one's easier. It doesn't matter which one you use, and always use the second one to check. So if I take 8x, I'm going to plug that negative 1 in exactly where x was, and I'm just going to solve for y. So this would be negative 8 minus y equals negative 6. Add 8 to both sides. Negative y equals, well, negative 6 and positive 8 would be 2, but that y still has that negative, so we're going to divide both sides by negative 1, and our y is going to equal, negative 2. So there is my solution, negative 1, negative 2. I'm going to plug that back in real quick. 2 times negative 1, negative 2, okay. And negative 3 times negative 2 would be a positive 6. So negative 2, positive 6, would that equal 4? Yeah, it does. All right, one more equation here we want to take a look at. One more system of equations we want to take a look at. Remember, 2 equations, 2 or more equations together make a system. So I have x minus 2y equals 3, 4x minus 8y equals 12. Number 1, I want a coefficient of 1. If I'm going to move it around, I want it to be easy. And so I'm looking for a coefficient of 1 so I don't get up nasty fractions, really, because that's just something we prefer not to work with because it takes more time. So I'm going to solve for x this time. So I have x minus 2y equals 3. Add 2y to both sides. And x is going to equal, looks like 3 plus 2y. Now I know x, and I found x from this equation, so I'm going to plug in my value into the other equation. So 4, again, I know x, so I'm going to plug it in. Be careful, it's tricky when you don't use x as often as you use y. So 3 plus 2y minus 8y equals 12. Distribute. So I have 12 plus 8y minus 8y equals 12. 12. What happens there? Those cancel, right? 8y minus 8y. Anything to subtract itself is gone, right? So then I'd have 12 equals 12. What to do now? Where'd my y's go? They're gone. What do we know about equations when our variables subtract out? Yeah, we look to see 12 equals 12. Is that a true or false? That is true. So if it's true, that means that I have infinitely many solutions. So this means that these two lines are the exact same line. Now just thinking about that. X minus 2y equals 3, is that the exact same line as 4x minus 8y equals 12? Are these equivalent? You're like, well, no, they don't look the same. But let's think. If I wanted this x to look like this x, I would have to multiply it by 4, right? So if I took, and this is not what you need to do, I just want you to show you. This is so you can kind of wrap your head around why is this happening. If I wanted this x to be a 4x like the other equation, I'd multiply it by 4. But when we have equations, what we do to one side in multiplication and division, we have to do to all. So 4 times x, well, that'd be 4x. 4 times negative 2y, that'd be negative 8y, equals 4 times 3, 12. 4x minus 8y equals 12. 4x minus 8y equals 12. Yes. These lines, when I graph them, if I put them both into y equals mx plus b, are going to be the exact same line. And remember, on a graph, when we have the exact same line, or when our lines stack on top of each other, we have infinitely many solutions. So be careful with those. If you're not sure, go back and make sure you didn't make an error with your calculations. But you can always graph it if you need to real quick, and that will just show you very quickly if you have a y equals mx plus b that are the same.